This example is from 6.4, solving trig equations using identity. This question we're asked to solve this one. Cosine of 2x equals cosine x. Double angle on one side, single angle on the other side, so we're going to need to use an identity to get rid of the double angle. The question is which one to use because cos 2x has 3. You've got cos 2x equals sine squared minus cos squared, 1 minus 2 sine squared, or 2 cos squared minus 1. The smartest one or most direct one to choose here would be 2 cos squared x minus 1. The reason being is that now everything is in terms of cos. We can turn it into a cosine factoring question. 2 cos squared minus cos x minus 1 equals 0. If you would have used one of the other identities, it's not that you can't solve it, but it involves one more step of using the Pythagoras identity to get yourself to this point anyway. So it's definitely the best one to use. I would probably say this is one of these ones where you let n equal cos x. So you can say I've got 2n squared minus n minus 1 equals 0. Hopefully that looks to you like a Math 10 problem. You could use quadratic equation if you're feeling really stumped and just can't factor these things. I'm looking for two numbers that multiply together to equal negative 2 and add together to equal negative 1. So negative 2 and positive 1 are my magic numbers. So I factor this by decomposition, saying minus 2n positive 1n. It still equals altogether the same thing, but now I can factor it 2 by 2 and say, okay, I've got 2n times n minus 1 plus 1 times n minus 1 equals 0. So I've got n minus 1 times 2n plus 1 equals 0. So n equals 1, or n equals negative 1 over 2. Now, nobody asked me for n. I invented n a minute ago, so I better go back to where I said this is cos x. So cos x equals 1, or cos x equals negative half. So where does cos x equal 1? It's right there. And so we have two answers, x equals 0, or 2 pi within the domain given. Where does cos x equal negative a half? Cosine is negative in this quadrant, in this quadrant. So I do have two answers, and they are 2 pi over 3 and 4 pi over 3. 120 degrees, 240 degrees if you did this in degrees, and then you'd have to convert to radians because of the domain we were given. So we do have 4 answers. Since we haven't done one, let's say in the second part of this, they say give us the general solution. That just means instead of stopping at 2 pi and 0, give us all the answers to this particular question. So you don't do anything differently up to this point. I mean, you still factor it and find these answers the same way, but then you say, how could I list all of these answers? So the first set, I would say x equals 0, 2 pi, 4 pi, 6 pi, 8 pi, so you could say 2 pi n, where n is any integer, and that would list this first set of solutions. The next one, you have 2 pi over 3, and then every 2 pi after that, you would have another solution. And then the last one, 4 pi over 3, and every 2 pi after that, you have another solution. Remembering that the period of cosine is 2 pi, so every time you rotate 2 pi, you'll find another answer that relates to the one that you've got. So general solution doesn't require factoring it all over again, but does require knowing how to list all of these answers in one step.